Hi, my name is Andy Williams, and this is my Lab 5 for Georgia Tech Physics 1. So for this lab, we got to choose what we wanted to examine, and I chose a falling cone and compared it with a hole in the top versus no hole in the top. So we'll examine that motion. What we're going to do is we'll examine it in Tracker and then also use code and compare the two. Now for this system, the net force is not zero because gravity is acting on it and the code speeds up in the negative y direction. So at the top here we have Newton's second law. The final velocity equals the initial velocity plus F net over m delta t. Now the net force is not just the weight force, which is gravity, m times g. It also includes the drag force as the air molecules push up on the falling object. Now this drag is turbulent drag, and we'll examine how that's calculated in the code later. Now, one way to model the motion is with code in a computer. So let's examine some of those lines. First, we have to set some initial parameters, like the cone's mass, which is equal to 0.005 kilograms. Now, the initial cone position is here. We got this from the tracker data. The initial velocity is 0 because it hasn't started falling yet. Now, j hat is the direction of gravity, and v hat is the direction of the velocity, which is initially j hat. Now, the weight force is down here. Now, this is equal to m times g, but it's negative cone dot m times g times j hat for the direction. Now the force of drag is equal to negative b, which is the drag coefficient, which is up here in the top right corner, 0.003, times the magnitude of the cone's velocity squared times v hat for direction. Now the coefficient of drag coefficient, is very important because I use that to see how the hole in the top of the cone affects the falling motion. But first we'll go down here. So the direction of the velocity equals the cone's velocity divided by the magnitude of the cone's velocity. We know this from vector math. Now the cone's position, this is just the position formula in code form. So let's examine the motion in Tracker first. So here is the cone with the hole in the top. As you can see, the cone falls straight down very nicely. Oh, and it's tracked over here. So you can see where it reaches terminal velocity and has a constant speed. Now, let's look at it with the hole in the top of the cone covered. Now notice that the axis is tilted. This is to follow the motion of the cone as it falls. And this will be important and will be discussed later, why it's tilted. Alright, so it falls pretty much the same way. So let's go back and look at the comparison on the graph. Now, as you can see, they start from the same place, but end up in a little bit different positions. The blue line here is actually the cone with the hole in the top, and the red line is the cone with no hole. Now, this is surprising because the cone with the hole actually fell for a longer time and didn't before it hit the ground. So this means it was actually going slower, which is counterintuitive because it has a hole in the top of the cone. So we can examine some of the reasons for that. And it has to do with parachutes as well. So I've always wondered why parachutes had the hole in the top, but it applies to this situation perfectly. As the cone falls, the air billows up inside and forms a pocket. Now, if the air has nowhere to go, then the parachute actually will tip sideways, the bottom will start to flutter like a jellyfish, and the person falling will have no control. So the hole is in the top of the parachute to let the air pass through to keep control, but also, and this is what's really interesting, is the air touches more of the parachute as it goes through, which slows the person down more. Because as you can imagine, see here, if this whole parachute is to fill up with air and there's no hole in the top, then it's basically like falling with a flat plane across this parachute. So you only get this surface area hitting air molecules and slowing you down. If there's a hole in the middle, the air passes through and actually allows air to fill the parachute and slow down as you're falling, more and more air. So that's really interesting and counterintuitive. So we can look at the tracker data again now that we know this, and this one is the one without the hole. See, notice this one falls straight down perfectly. This actually, it doesn't spin and oscillate as much, so you get more air in the cone, slowing it down as it falls. But this video shows the cone, and as it falls, it slides to the left, and it actually, it's hard to tell, but it turns more so that the cone falls faster because it has to have a place for that air to go that billows up inside of the cone because it can't pass through the top. So, if you're ever falling and you're in a and you need a parachute, you should probably have a hole in the top so that you can control how it falls. Thank you very much.